Welcome to the DIY Honda Garage channel. DTC P0191 denotes a problem with the fuel rail pressure sensor circuit in the Honda Civic model years 2006 to 2011. This diagnostic trouble code indicates that the performance or range of the circuit is not within the expected parameters. The fuel rail pressure sensor plays a crucial role in monitoring the pressure inside the fuel rail and communicates this information to the Powertrain Control Module, PCM, to optimize fuel delivery. If the sensor fails or shows incorrect readings, it can adversely impact engine performance and efficiency. The correct operation of the fuel pressure regulator is also essential, as it helps maintain the appropriate pressure and flow of fuel to the engine. Location-wise, the fuel rail pressure sensor is situated directly on the fuel rail, responsible for detecting the level of pressure in the fuel system. DTC P0191 refers specifically to a malfunction within the fuel rail pressure sensor circuit. This sensor is vital as it gauges the fuel pressure present in the fuel rail, which is essential for optimal fuel injection into the engine. The PCM uses inputs from this sensor to adjust fuel delivery according to engine demands, ensuring optimal combustion and performance. A malfunction can lead to either too much or too little fuel entering the combustion chamber, causing poor performance or even stalling. The sensor is physically located on the fuel rail, making it easily accessible for inspection without disassembling extensive engine components. Correct functioning of this sensor contributes significantly to overall engine efficiency and power output. Several possible causes can lead to the P0191 DTC being triggered. A loose or damaged vacuum line connected to the fuel pressure regulator can inhibit proper operation and monitoring. Fuel leaks throughout the system can alter the pressure readings, causing the sensor to report erroneous values. Additionally, a faulty fuel rail pressure sensor may not accurately measure fuel pressure, leading to performance issues. Moreover, the fuel pressure regulator might be defective, preventing it from maintaining the appropriate fuel pressure needed for engine operation. Each of these factors can affect fuel delivery and performance, necessitating a thorough evaluation of the fuel system to accurately diagnose the issue. The presence of DTC P0191 can manifest through various symptoms related to engine performance. Drivers may experience a decrease in overall engine performance, leading to awkward driving conditions. Stalling or hesitation can occur, particularly during acceleration, as the engine struggles to receive the correct amount of fuel. Poor fuel efficiency is another symptom that can arise, resulting from an imbalance in the air-fuel mixture caused by incorrect pressure readings. Additionally, the check engine light will be illuminated on the dashboard, serving as an indicator that there is an ongoing issue that requires attention. Understanding these symptoms is crucial for timely diagnosis and repair, helping to prevent further damage to other engine components. The first troubleshooting step in addressing DTC P0191 involves checking the condition of the fuel pressure regulator vacuum line. This line is critical for ensuring the regulator functions properly by maintaining the correct fuel pressure within the system. Inspect the line for any signs of damage, such as cracks or disconnections. If the line is found to be loose or damaged, reconnecting or repairing it is necessary before proceeding. This step is vital, as an improper vacuum connection can not only trigger the DTC, but also lead to erroneous fuel pressure readings impacting engine performance. If the line is intact, you can proceed to the next step in the troubleshooting protocol. In the second troubleshooting step, turn the ignition switch to the on position without starting the engine. This allows the fuel pump to prime and pressurize the fuel system. During this process, thoroughly inspect the entire fuel system for any signs of leaking parts. Fuel leaks can significantly impact the sensor's ability to report accurate pressure readings, causing the P0191 code to appear. If any leaks are discovered, it is crucial to replace the damaged components before continuing with further diagnostics. Conversely, if no leaks are present, you can advance to the subsequent step in the troubleshooting sequence where further testing can be done. The third troubleshooting step requires starting the engine and holding the RPM at 3,000 without any load. This step is performed to ensure that the fuel system is operating under increased demand and allows for the monitoring of engine performance. Holding the engine speed at this level until the radiator fan activates is critical as it simulates real driving conditions. Following the activation of the fan, allow the engine to return to idle. Doing so provides necessary data for subsequent steps in the diagnostics by allowing for a thorough assessment of the fuel pressure readings during varying RPM levels. This step assesses the system's response under different operational conditions and highlights any potential issues that may arise. Step 4 involves taking the vehicle for a test drive under varying conditions while closely monitoring the onboard diagnostic system. This step enables you to capture and assess live data pertaining to the vehicle's performance, specifically focusing on parameters like engine speed and manifold absolute pressure (MAP) sensor readings. It is crucial to monitor the onboard diagnostics OBD status, particularly for DTC P0191, through an appropriate diagnostic tool such as the Honda Diagnostic System HDS. If the status indicates failed, further diagnostic steps are necessary. If the indication is passed, this may suggest that the issue is intermittent, prompting an inspection of wiring and connections. Should the status remain executing, continuing to drive the vehicle will provide additional data. Overall, this driving step is essential for identifying how the vehicle behaves under actual driving conditions. In this step, you will again start the engine, maintaining it at idle. Once stabilized, the next action is to snap the throttle, rapidly increasing the engine speed to 3,000 RPM or higher. This quick action emphasizes dynamic response under stress in the fuel system, and it is critical for assessing the operation of the fuel rail pressure sensor. During this snap event, utilize the HDS to monitor the fuel rail pressure sensor's readings. The sensor should reflect a change of at least 4 kilopascals, 0.6 psi, indicating that it is responsive and operational. If the reading does change, it confirms that the sensor is functioning correctly. If not, continue to replace the sensor in subsequent steps. Monitoring the sensor's performance during this dynamic condition is essential in determining overall system health. During the 6th troubleshooting step, after ensuring the engine is at idle, check the fuel rail pressure sensor readings in the HDS. The expected values should be in the range of 204 to 326 kPa, which translates to approximately 29.6 to 47.3 psi. If the sensor reading falls within this range, it confirms the functionality of the system, allowing you to proceed to further tests for other components like the MAP sensor. However, if the reading is outside of this normal range, the next step is crucial as it indicates a fault in the fuel system. It will be necessary to address this issue in the following steps, which could involve inspecting other related components. Understanding the expected idle values assists in identifying whether the fuel pressure management system is functioning correctly. At this juncture, turn the ignition switch to the lock position to ensure safety before any disassembly work is performed. The next action involves removing the fuel rail pressure sensor itself, which requires caution to avoid damaging any surrounding components. After disconnection, reconnect the sensor's 3P connector securely to ensure accurate readings during subsequent tests. Proper reconnection is critical, as voltage and ground provided by the connector are integral for sensor performance. This step lays the groundwork for testing the sensor's functionality against other critical sensors, like the barometric pressure sensor, BARO. It is paramount to confirm that all connections are secure to obtain reliable diagnostic information moving forward. In this step, with the ignition switch back to the on position, you will examine the values reported by both the barometric pressure sensor and the fuel rail pressure sensor as displayed in the HDS. Comparing these values allows you to determine if there's a significant discrepancy of 22.3 kilopascal, 3.23 psi, or more between the two sensors. If a considerable difference is observed, it indicates a fault with the fuel rail pressure sensor, prompting its replacement as the next action. Conversely, if the readings are consistent, the problem may lie with the fuel pressure regulator instead, warranting its replacement as outlined in the next steps. This specific comparison serves as a diagnostic tool to pinpoint deficiencies in either sensor responsible for fuel management. After executing all the necessary repairs related to the identification of DTC P0191, the final verification of the repair process must be performed. This involves validating the effectiveness of the repair work by using the diagnostic system to clear any stored DTCs. Once cleared, conduct a test drive under normal operational conditions to confirm that the previously indicated code does not reappear. It's essential to monitor engine performance during this test, ensuring that the vehicle operates smoothly and efficiently. In conclusion, this step is vital, as it not only checks the success of the repair, but also helps verify that all related systems function optimally post-repair. To prevent recurrence of DTC P0191, regular maintenance is key. Conduct periodic inspections of the fuel system to ensure that all connections, including vacuum lines and electrical connectors, remain secure and undamaged. Addressing any signs of wear or damage immediately can avert larger issues down the line, enhancing the longevity of components such as the fuel rail pressure sensor and fuel pressure regulator. With proactive measures in place, it becomes easier to maintain optimal engine performance and fuel efficiency. Creating a scheduled maintenance plan can help keep track of these vital checks, ensuring the reliability and performance of your Honda Civic's fuel system. In conclusion, DTC P0191 signifies a fuel rail pressure sensor circuit problem that necessitates thorough diagnostic procedures. Systematic troubleshooting steps are essential for isolating the underlying issue and ensuring effective repairs. Regular checks of the fuel system not only help identify potential problems early, but also enhance the vehicle's overall performance and efficiency. By following the defined diagnostic steps, technicians can effectively address and rectify the issues related to this trouble code and maintain optimal vehicle operation. Addressing issues promptly and consistently checking system integrity is vital for preventing future occurrences of this DTC, ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time!